Hello everyone, my name is Nick McKincheck, and in my video I'm going to be discussing how to calculate entropy change for a composite process. So to get started, it's important to overview what entropy in a composite process is. So as we know, entropy is a measure of randomness or disorder of a system, and it's important to note for a composite process that entropy is a state function. We'll get more into that in a little bit and why that's important for a composite process. So what is a composite process? A composite process is when there's more than one parameter change in a process. So this could be a change in the initial final states when there's a difference in temperature or volume or both or pressure. So these two changes, so to calculate the entropy change for a composite process where there's a change in temperature or volume or both, we're able to separate this composite process into different steps and then calculate the entropy change for each step to find the overall entropy change. And this is because entropy is a state function, so it's independent of the path of the initial and final. So for example, say we have an isothermal expansion followed by heating. So this scenario could be broken into two steps. It could be broken into the isothermal expansion and then also the heating. So we could calculate the entropy for each of these steps and then sum together the entropies to represent the total entropy change for this composite process. So now this example problem, it's from Focus 3 in the textbook. So it says calculating entropy change when argon at 25 degrees Celsius and 1 bar in a container of volume 0.5 decimeters cubed is allowed to expand to 1 decimeter cube and is simultaneously heated to 100 degrees Celsius. Take the molar heat capacity at constant volume to be 3 over 2R. So the steps to solve this problem first would be to break the composite process into two separate processes. So the first, we could separate the isothermal expansion, and then the second step would be the heating. So we know the equations to find the entropy change in each of these different steps already. So we're able to use these appropriate equations and solve for the entropy change of each step of isothermal expansion and then the heating. And then finally, we're able to sum together the entropy change for each of these processes to get the total entropy change. So the first thing we need to do is, because the equations that we know need the amount of moles in them, we're going to calculate the amount of moles of this gas using the gas equation. So given the pressure, the volume, and the temperature, we're able to find the amount of moles in the equation. So we do that in the first step, so we're able to use the equations. So this first step, we mentioned that it's going to be isothermal expansion. So we're able to calculate the entropy change of isothermal expansion using this equation here, taking into account the initial and final volume, and then plugging in the values that were given in the equation in the problem, we're able to calculate the entropy change for this step. So then the second step we said was the heating. So in the heating, we're given this equation that takes into account the heat capacity and the moles, and then the initial and final temperatures. So plugging in these values, we're able to calculate the entropy change for the heating step of this problem. And then finally, as I said, since entropy is a state function, we can then sum together these two entropies that we found using the appropriate equations for the step and find the total entropy change for the composite process found here. So overall, in this equation, we broke down the process into two separate steps, and then we used the appropriate equations to calculate the entropy for each specific step. For example, here we did the isothermal expansion entropy, and then we did the heating entropy here. And then finally, we took the sum of these two values to find the total entropy change for this composite process. So in summary, the total entropy change of a composite process can be found by dividing the process into multiple steps, finding the entropy change at each step using the appropriate equations, and summing the entropies together to give the total entropy change. So I also included some important equations to know that are going to be used for composite processes. So in our example, we had the isothermal expansion and then we had heating. So these are the equations to find the entropy for those two processes. It's also important to know the entropy of transition, which is going to be utilizing the enthalpy transition value, and then also the transition temperature value. So overall, I hope I was able to demonstrate how to find the entropy change for a composite process. There's a lot of other good practice problems in Focus 3, especially ones that include also finding it for phase transition processes. So those are going to be good examples to also do to prepare for the final exam. But I hope this was able to steer you the right way and help you gain a better understanding of calculating entropy change for a composite process. So with that, I hope everyone, I wish everyone good luck on the final exam,